Welcome to the 1Keydata data warehousing tutorial. In this video, we talk about a common issue in data warehousing, namely the attributes of an entity sometimes change over time. This is called the slowly changing dimension problem. We will first give an example of this problem, and we'll discuss the various ways to resolve this issue. But first, if you haven't subscribed to this channel yet, please do so now. Imagine you have a customer. When this person became a customer in 2010, this person lived in New York. In 2015, this customer moved to Texas. And in 2020, this customer moved to California. Here we have a customer whose attributes has slowly changed over time. Specifically, the state this customer lives in went from New York to Texas to California. In data warehousing, this is considered as a slowly changing dimension problem. This is a common issue in data warehousing, and there are several ways to handle this. First, there is type 0 slowly changing dimension. In this method, we do not update the table at all. The table you see here holds the same value throughout its history. The advantage is that it is easy to implement and doesn't require any additional data storage. The disadvantage is that we lose our ability to track any changes over time. Also, because this approach does not update values, we will not know what the current value is. Next, there is type 1. In type 1, new data overwrites the old data and no history is retained. In our example, in 2010, we will see this customer is in New York. In 2015, this customer is in Texas. In 2020, this customer is in California. The advantage of type 1 slowly changing dimension is that it is easy to implement and does not take additional storage or tables to store historical data. The disadvantage of type 1 slowly changing dimension is that no historical data is kept. For example, if you want to know where the customer was in 2010, you will have no way to find out because that data is lost. Next, we introduce type 2. In type 2, a new record is added to the table to represent new information. To do this, we'll need to modify the schema of the dimension table. In particular, we want to accomplish three things. First, we need to ensure there is a natural key that represents each element. Second, there is a way to identify what the most current version is. Third, there's a way for us to locate the historical value at any given time. There are a number of ways we can modify the schema to do this. In our example, we will introduce three additional columns: a surrogate key column, a create date column, and a current flag. Let's see how we use type 2 to track our changes here. In 2010, there is only one entry in the table. Note that the surrogate key here acts as the unique identifier for the table. The customer ID key represents the customer. The current flag is set to yes, indicating that the customer's current state is New York. In 2015, there are now two entries in the table. Note that the surrogate key is different from the first row, but the customer ID column remains the same. Also, now the row with Texas gets the yes value for the current flag. In 2020, there are now three entries in the table. The current key is set to no for the first two rows, while it is set to yes in the last row. The advantage of type 2 slowly changing dimension is that it allows us to accurately track historical changes. The disadvantage of type 2 slowly changing dimension is that each row no longer represents a data element. Rather, it represents each version of each element. This makes the schema more complicated and may cause confusion for people who are trying to write a query using this table. In addition, this will increase the size of the table, which could lead to scalability issues. Also, this can make the ETL process more complicated. Next, we have type 3. In type 3, each element is only represented by a single row, and additional columns are introduced to the dimension table to track changes. Since only a limited number of columns can be introduced, not all the changes can be tracked. One possibility is to track both the original value and the current value. Another variation is to track the current value and the most recently changed value. Let's look at how we would use type 3 slowly changing dimension to track our customer. In 2010, we have a record that shows the customer is located in New York. In 2015, this record is modified to show that this customer is now in Texas, with an effective date of August 1st, 2015. Here, we still know this customer's first state was New York. In 2020, this record is again modified. Now it shows that the customer is in California, with an effective date of July 1st, 2020. We still know this customer's first state was New York. However, we no longer have any trace that the customer was once in Texas. So, what are the advantages and disadvantages of type 3 slowly changing dimension? The advantage is that at least some of the historical changes is captured, and only a small amount of additional storage space is needed. The disadvantage is that this approach does not capture all of the historical data. Here we have a trade-off between less storage requirement and incomplete historical data. There's another type called type 4. In type 4, a history table is added to track the history. So in this case, you have a regular dimension table that keeps track of the current values. And when historical data is needed, one can refer to the history table. This history table will have a different schema from the dimension table. For example, it may contain a surrogate key, or it may contain a start date and an end date to indicate that the state of this record at any given time. Let's look at how we would use type 4 slowly changing dimension to track our customer. In 2010, we have two tables, each with one record, both indicating that the customer is in New York. In 2015, the dimension table continues to have one record, but the state is now Texas. A new row has been added to the history table to show when the customer state was updated to Texas. In 2020, the dimension table still has one record, and the state is now California. A third row has been added to the history table to show when the customer state changed from Texas to California. So what are the advantages and disadvantages of type 4 slowly changing dimension? The first advantage of type 4 is each row in the dimension table represents one element, which makes querying and understanding the data easy. A second advantage is that all change history is tracked. On the other hand, one disadvantage of type 4 slowly changing dimension is that this introduces a new table into our schema, which leads to increased complexity and additional storage requirements. Also, this can make the ETL process more complicated. In addition to the 5 types of slowly changing dimensions we've discussed so far, you'll find type 5, type 6, and type 7 in literature. They are rarely used in production environments, and hence we do not include those in this video. So which approach is most useful? If you want to track slowly changing dimensions, type 4 and type 2 are most commonly used. If not, you can use either type 0 or type 1. Between type 0 and type 1, type 1 is much more common because there is usually much more value to track the current state of an element than to keep the original state of an element. At the end, your decision will be primarily based upon your use case. For example, you may decide some attribute changes are worth tracking and others are not. In that case, you might decide to use type 0 or type 1 for attributes that you don't need the history for, and implement type 2 or type 4 for attributes where you do care about history. Thank you for watching this tutorial. To learn more about data warehousing, please visit 1Keydata.com.